Hello all, welcome to this webinar and thank you for joining. My name is Bas Hoksberg and I'll be your host today. My colleague Ryan Sainsbury will be presenting this webinar. We expect this webinar to take about 35 minutes. If you have any questions, please use the Q&A or chat buttons at the bottom of your screen to get in touch. We might answer the questions on the fly or at the end of this webinar. I see a nice list of attendees and hope we can make this interesting for all of you. So without further ado, let's get started.
Thank you very much for that, Baz. I'm just going to quickly share my screen. One moment, please. Hello, everyone. My name is Ryan Sainsbury. I'm Technical Project Specialist for Pharos Architectural Controls. So today's webinar is all going to be about integrating with third-party lighting protocols. So in particular, we're going to be looking at Cicato, Philips Hue, Dinette, and also Casambi. Just want to start off with a quick introduction note. As you're aware, Pharos supports various different types of protocols: DMX, ArtNet, KaiNet, now SPI. All of those are really suitable for nice dynamic lighting. If you want to map media content, if you want to build a really nice dynamic lighting show, they're typically the types of protocols that you want to use. Pharos also supports more architectural-based protocols, I suppose you could say, stuff like Dali. But today we're really looking at other third-party manufacturers. And to do the integration, we're going to be specifically looking at I/O modules that extend Pharos's functionality, something that we've talked about quite a lot in the last couple of webinars. So in order to integrate with these third-party manufacturers, a lot of the time you'll need a gateway. These gateways are required for our integration because they act as a go-between between Pharos and the third-party manufacturers. And you'll also need to set up the third-party manufacturer software, hardware, using their own software and their own configuration steps. So do be aware of that. There is some setup out to be done outside of Pharos. One final thing just before we move on, all of the protocols that we are going to show you today are command-based protocols. They're not really intended for dynamic lighting. When I talk about dynamic lighting, what I really mean is mapping media content or doing, sonnet luminaires or really interactive light shows. It's very much a case of we send it a command, the fixtures go to a certain scene, or maybe they go to a certain level or a certain color, and we're not going to be streaming lots of data back and forth between them. So first of all, I want to look at Cicato. Cicato is a really interesting protocol. It uses a Bluetooth mesh topology. There's a couple of advantages to this. First of all, you don't have to run any data cables, which can potentially save on installation costs. Can be particularly useful for an easy installation, especially if you're working with something like a grade listed building. But also the Bluetooth mesh network is really, really good because it doesn't have a single point of failure. If you imagine DMX line, if a fixture goes bad or if there's something wrong with the cabling, any fixtures beyond that point may not receive data. With the mesh style topology, if a single unit goes down, all of the other devices can relay commands in and around it. So you still get your commands being transported around the network. Now, Pharos does not support Bluetooth at all. We will need a gateway between us and the mesh network. We send HTTP commands to the Cicato gateway. The Cicato gateway then just relays that information on to the rest of the network. The communication between the gateway and Pharos, as I've said, is HTTP. So you will obviously need a computer network, a Cat6 style network. But also the HTTP request, as well as commanding the system, can also be used to retrieve data back from the system. So we can query the system, get information back from, say, Lux sensors, and then use that data to then obviously run a new routine within Pharos. So the first thing that I just want to have a look at is just downloading the module and then having a look at its documentation. So I'm going to show this once. It's pretty much the same procedure for all the modules that I'm showing you today, but just a quick reminder. Top right hand corner, hit modules and scripts. Once you do that, in the left hand corner, you'll have all of your library load up. As soon as your library loads up, you can obviously have a browse through and have a look at what modules you've got. You may already have the Cicato module, brilliant, but it's definitely worth checking if there's a new update available for it. We do update our modules quite often, so do go ahead and do that. In any case though, if you do want to update or download the module, once you've opened up the scripts and modules tab, just hit the download button in the top bar. Once that opens, have a quick search for Cicato. The module will come up, and the first thing that you'll notice is that we have a version and then we have an existing column. Version column is the most up-to-date version that we have released. Existing is just what's existing within your project file or within your version of Designer. You can also look at the documentation as well. This is new in 2.8. Just have a quick read through the documentation, obviously at your own leisure. But specifically, we'll be looking at actually a part of the documentation, which I'm going to show you in a little while, which is going to be the configuration section. And this configuration section is really important because this will give you a couple of tips as to how you can configure the Xicato hardware. So make sure that you do that first before trying to integrate Pharos with it. Obviously, Xicato needs to be set up. You will need to do that through the Cicato tools that are provided to obviously get that system up and running. But assuming that you followed those steps and you've got Xicato set up, then of course we can go ahead and we can start programming with Pharos. So once the module's loaded up, the first thing that you'll need to do is fill in a gateway address. This is the IP address that we're going to be making HTTP requests to. You can just fill this out within the module's properties as shown on screen. There's also a port number. I believe this is just a default port number that we set. You may need to change this in Cicato as well. You can certainly update it in Cicato as well as the IP address. And then finally, you'll need a network name, username, and password. And again, this is all stuff that will be set up within Cicato. You just need to transfer that information over to Pharos. Now, one of the things that is important is this poll interval. We will regularly poll Cicato for information. This is how often we are getting those updates. We've set it to 1 minute, i.e. 60 seconds. We think that's quite a good rate to set it at. I'd be a little bit careful of making it too quick. You don't want to be sending loads and loads and loads of HTTP requests out to the Cicato gateway. You might overload it. Once a minute is absolutely fine though, and you can obviously adjust that time if needed in the properties shown on screen right now. Also, one other thing as well, you have the option to start polling at startup. You can start and stop polling with different actions, but you can just have it start as a default. I've kept that selected. And finally, you have an option to extend the logging, which obviously will produce more of an in-depth log within Pharos and within our controller's log. So once you've got that all set up, we can go ahead and we can start programming. So a couple of routines that I'm going to show you today are just meant as examples. Obviously, you can program this however you want. You can mix and match any condition, any action within Pharos, regardless of them being in a module or not. First thing I'm going to do, though, is I'm just going to have a startup trigger, and that's just going to check the status of the gateway. We want to make sure that that gateway is online before we do anything else. There's an action for this. Just attach it to a startup trigger, and the action is called get gateway status. So this will just make a HTTP request to the gateway, just asking if it's there or not. And then in order to actually handle the response, we'll need a trigger. This is the gateway status changed trigger. And then once you've selected that, you should see that you get an online and offline status. And basically what's happening there is if we get a HTTP 204 call sign, an OK call sign as it's known, then we obviously know the device is online. If we don't have a call sign returned to us, then we populate a 404 or a 0. In any case, though, we know that the device is not online because it hasn't responded. So set this to online, that trigger will fire since we get a response from the gateway, and from then on in, we can then start our programming. Now, one of the things that I really, really like about Cicato is that you can set scenes via HTTP requests. We have an action to do this. The action is called set scene, and then effectively what you can do is you can kind of program scenes into the Cicato system. First thing you'll need to set up is an ID. These IDs can be used for various different things within the Cicato framework. Sometimes they're just identifiers or labels. Sometimes they're device names, or sometimes I believe they can even be used to group different devices together. In any case, for scenes, it's just going to be a reference for us. You'll obviously need to pick a scene number as well. And then finally, you'll just need to set the scene properties, the intensity, fade time, etc., etc. So make sure that you have that set up. I'm going to then go ahead and actually set up two different scenes that I want to create on startup, just adjusting the ID, adjusting the scene number, then just adjusting the other properties such as the intensity or fade time. So just a quick reminder of what we've done there. We've had a startup trigger fire. That then obviously sends out a HTTP request to the gateway, checks that the gateway is online. If the gateway is online, what I want to then go ahead and do is run a routine, which is then going to program some scenes onto the Cicato gateway. So Once that's done, I may want to then obviously recall these triggers at a later point in time, or recall these scenes rather, and I can do so just by using any old action within Pharos. Because they're nighttime, daytime scenes, I think what I'm going to go ahead and do is use an astronomical trigger. So I'm happy with the way that's set up. What I'm going to do now, as I said, add an astronomical trigger. That astronomical trigger is then going to basically just recall those scenes. So I'm going to do the daytime one first, and I can use the recall scene action, pop in the ID, pop in the scene number. HTTP request will obviously use that information then to recall that scene. Likewise, if I want to do the same thing but at sundown, at nighttime, again, just change the ID, change the scene number, and there's also a fade time there, which I believe that you can adjust if you want to override the default. So that's it. We've got setting scenes, returning scenes, pretty simple. One other thing that I want to show you is just actually how we deal with information coming back from the Xicato system. As I said, we have the ability to interrogate the system for information for things like lux sensors. As we're automatically polling that system anyway, all we need to do is just set up a trigger. There is a lux sensor trigger if you have a lux sensor within the Xicato system. You can just pull that into Pharos. Then once that's pulled into Pharos, just set the ID for the sensor name. You can leave blank if there's only one ID, or if you want to have the data returned from any sensor, and then just attach an action to it, something like a master intensity. Just remember that obviously we want to use a variable here because we want it to be dynamic. The Cicato system, I believe, will return a value to us, which will then store as a variable, which can then obviously be used within that action. Pretty nice and straightforward though. And obviously you can see that there's quite a lot of different triggers and actions that can be used with the Cicato system to get back information as well. So I want to move on because we've got a lot of stuff to look at today. So the next thing that I want to have a look at is Philips Hue. So it's a similar kind of concept. We have a bridge. This bridge sits between Pharos and the Philips Hue bulbs. And then you have this wireless protocol called Zigbee that Philips uses for creating kind of a small network between the fixtures. And of course, we'll send HTTP requests to the Hue bridge. The Hue bridge will then relay that information onto the wider Philips Hue system. Again, between us and the Hue bridge, it's HTTP. You'll need just basically an Ethernet cable or some kind of computer network set up. The one difference between Hue and something like Cicato, though, Hue is more for the residential market. I think it's a little bit more basic. You can't return as much information from the system. It's, again, just more kind of command-based. But again, it's still pretty powerful, and it may be something that you want to integrate with Pharos. So let's have a look at the module now. So we have the module properties, first of all. First thing that you'll need to set up is, of course, the IP address where we need to send the HTTP request to. That's the bridge IP address, and then also a username. Now, one thing that's really, really important, you'll see that there's quite a long list of configuration steps that you need to take in order to get the Philips Hue system working with Pharos. Make sure that you do this because a lot of the information that you'll need within your triggers and actions, which I'm going to show you in a bit, you'll get from the Philips Hue system. So again, have a read through that. That'll then get you set up. You'll be able to obviously set up the Hue system, retrieve that information, which we can then later use in our programming. So configuration steps, by the way, in the documentation, they're highlighted now on screen if you're wondering, just in case where they were. Okay, so I'm just going to start with, again, some basic programming just to give you an example of what you can do. I'm going to use touch button event triggers, so as if I'm using a TPC screen. So I've got a touch button event trigger. Just type in a button number. This will obviously correlate to an interface TPC button press. And then you can then go ahead and then use whatever actions you want to, really. The first action I'm going to use, though, is just going to be to recall a scene which has been loaded onto the Philips Hue system. So by hitting recall scene, you'll have a couple of different options that come up. First of all, there's the group number. So you can fit group fixtures together in Philips Hue. They are effectively for like zonal control, and that's just designated by a number, much like it is with Pharos. One thing that you might notice, though, is that there is a scene ID underneath that. That scene ID is an ID that's populated by the Philips system. You will need to get that from the Philips system in the configuration steps and then pull that over, copy and paste that over into Designer. That's effectively how we actually make a request for that scene. So those two things are really, really important. Obviously, hit the right group number and hit the right scene ID. So again, I'm just going to use like TPC kind of button style triggers to kind of show you some of the examples, but you can really use whatever triggers you want within Faros. You have that flexibility. Within the Philips Hue system, you can also set colors. So for instance, I'm using a set RGB action now. Again, you have the ability to either set it to a single light or a single group. One thing that I should mention as well, the group number can be set to 0. That group number being 0 will obviously select all fixtures, okay, all fixtures. And also, yeah, as you can see in this screen that I've just showed you, you have the ability just to dial in RGB values, particularly in this action. But that group number can be set, I believe, within any action if you want to select all fixtures. Okay, so just a couple of other things now. I've got a real-time trigger. Maybe I want to have something happen at like 2 o'clock in the morning. Maybe I want the lights to dim down, and then maybe I want them to come on with like a relay input. So if I want to control something like the brightness, I can do that using, again, the set brightness action. Just like before, just filling out the parameters within the action however you want. Obviously, selecting between a single light or group. 0 selects all fixtures, and of course you can just put it in whatever intensity value you feel necessary. And likewise, if you know you've got a relay switch on the wall and you want to bring the lighting back up for whatever reason, you can again just do pretty much the same thing. Just have a digital input, set the brightness level, and of course that will then just raise the brightness of the system. But there's quite a lot of different actions there. I believe you can control things like color temperature as well as RGB values, brightness, etc., etc. Okay, so now I want to move on to probably the most architectural, I don't know if that's the right time to use, protocol, and that's Dynalite, Dinette. So Faros has actually been integrating with these systems for quite a while now. There are 2 different versions of Dinette that we can support. There's the Dinette over IP version, which utilizes either UDP or TCP. And then there's Dinette over RS485 over a serial connection. So first off, we're going to look at Dinette over IP. So you've got Faros, and then you've obviously got your Dinette bus. And in order for Faros to integrate with that bus, you'll need a PDEG, a Philips Dynalite Ethernet gateway. And again, it's just another gateway. We send commands to it via either TCP or UDP. You can pick which protocol you want in the protocol properties within the module. And then, of course, once we send the gateway, that command, it will then, of course, just send that data across the bus to any other Dinette devices that are listening out for that information. The RS485 version, the serial version, is good as well. Faros can sit directly on the Dinette RS485 bus. So we sit directly there and, of course, just send out commands without the use of a gateway. Very nice and simple to set up. So you've got 2 options there. You can either use the over IP version where you need a gateway, or you can just have the RS485 version and then, of course, just have us sit on the bus. The RS485 version is great for using LPCs. If you're using like an LPCX or a VLC, in particular, the VLC has an RS232 port, so obviously you'll probably need something like a gateway. But in any case, you have the flexibility. So let's have a look at the module. So I'm going to show you the TCP version, the IP version today. Just a quick thing, the IP version and the serial version is pretty much exactly the same. The only difference is that the properties that I'm about to show you would be a little bit different if you're using IP as opposed to something like the RS485 version, because obviously RS485 doesn't use IP addresses. In any case, though, I'm going to start by filling out the gateway address. So I've done that. I can also pick from the protocol, so TCP or UDP, as I said, you can pick. And then you just have a couple of other settings that you need to fill out, such as the port number that we send and receive on. Now, there is one important thing that you can see here, which is the area. Now, effectively, the area is the area number that gets designated to the I/O module. So when you're in System Builder and you're designing your system, You can obviously group your devices together by areas. This is just effectively that for Pharos, right? You're giving Pharos an area number, so when you send commands out, Pharos knows whether or not that command is for itself. Now, the default that we've got here is 0 because that's how the Philips Dynalite system is normally set up. Devices that don't have an area get the area of 0. I believe that's either for kind of like a panic command where you want to just have all devices respond. So it is definitely advised that you change that to a suitable number. Again, you set up these area numbers within System Builder, and of course, you just then pull that information over to Pharos. Pharos then gets that information. Of course, we just respond to commands that have that area number attached to it. It is an area number per IO module, though. So if you've got multiple instances of the IO module, you can actually adjust that area number to have different instances of the IO module react to different area commands. In any case, though, you can set it up. It's fairly easy to do within our properties, and we can then basically go ahead and we can then start programming. Make sure that you have a read of the documentation, though. We have a couple of kind of cheat sheets on here, as you can see in front of you, that should just help you get set up on the Dinette side of things and just make that a little bit easier. Okay, so I'm just going to go ahead now and I'm going to start some basic programming. The first thing that I'm going to want to do, as I've kind of shown in the Xicato module, is just basically run a very, very basic startup routine. So I've got my startup trigger here, and the first thing that I'm going to do is I'm actually just going to request some information, some data from the Dinette system. And in particular, what I want to actually request is the current preset that's being played in another area. So Pharos boots up and it says, okay, what's that area doing? Obviously gets that information back, and then that helps Pharos determine what it should be doing. So we have an action to do that. First of all, you'll need to select the area where you want to get information from. That information then will get returned to Pharos. You'll have a response trigger to handle that. Obviously, the response trigger in the left-hand side is going to be the current preset reported trigger. And then finally, you can just set the area, and then you can also set the preset to a specific number if you want to trigger from a specific preset number, or any which will create a variable, which we can then use to obviously start a timeline. So once I've got that information back, maybe I want to control the system, and we can also do that as well. We can have a digital input trigger fire when a relay changes state. And then we can just apply that to a set of actions. So first of all, start off with a timeline that's going to be started internally with Pharos, and then I'm going to want to send out a command to the Dinette system in order for it to then recall a different preset as well. So using the set area user preset action as shown on screen, we can pick something like just a preset number 1, for instance. We can also give it a default fade time, and then of course we can set the area number that we want to target. So we've got a very simple way of obviously controlling the Dinette system using those actions. And then I'm just going to show you a couple of other typical examples of programming that you might find within a Pharos system when it's integrating with Dinette. So let's say we have a real-time trigger that fires. Maybe we want to, I don't know, control part of the Dinette system, maybe turn it off, for instance. I can just set up a quick basic real-time trigger. So this is going to be set for 2 a.m. in the morning. And then what I'm going to do is I'm going to basically create a blackout in one of the areas. And to do that, I'll release all the playback within Pharos first. You don't have to do this. This is just obviously controlling our own internal lighting. The point that I'm trying to make here is that obviously we can do both at the same time. So that release always going to, obviously release any playback that we're doing. And then we can set an area to off using the area to off command, and then of course just picking the area and then setting a fade time. So yeah, really, really useful if you want to control something like DMX and Dinette. Obviously Pharos can do all the DMX stuff just by running normal timelines and releasing them, and of course we can also send commands out to the Dinette system in order for it to then just be controlled by us. If, however, we want to respond to commands coming from the Dinette system, we have a couple of different triggers for that, as you can see on screen. Just to give you an example, we have the set area to user preset. So this is for incoming commands. We just need to assign an area number that we want to respond to. you can leave it to 0, or you could obviously leave it to the instant preferences or set a number. It's completely up to you. And then finally, if you leave the preset number to any, that'll obviously then create a variable, and we can use that variable to start timelines using a start timeline action. So we can be controlled from Dinette as well as controlling that system. Okay, cool. Right, last protocol that I want to look at today is Casambi. So Casambi is a proprietary protocol. It's not a protocol that's shared publicly, but we can integrate with this system. We do get asked this quite a lot. Our method of integration that we would recommend is using Dali. And there are a couple of different reasons for this. First of all, it does give you quite a lot of control. You can do color control with our Type 8 support, and also sorry, and also there is a Dali gateway, CBU DCS, which you can use to integrate Pharos with the Casambi system. Now, triggering Casambi scenes that have been loaded onto the Casambi system is not currently possible, but hopefully we're looking at extending our functionality in the future. Obviously, there is a third-party manufacturer at play here. We'll also need to see what they do as well. So just a quick look at the Casambi system. The Casambi system uses BLE, or Bluetooth Low Energy, for its transmission of commands. As I've already said, Pharos can integrate with this system using Dali. So you'll need a Rio D or TPC EXT combination to do that. You'll need a Dali port. And then you'll obviously need the Casambi Dali gateway, which is displayed on screen as well. Obviously, we'll then just send Dali-based commands to the Casambi system. The Casambi system will then relay that information to its fixtures. And obviously, that will be your method of control. Now, in terms of actually how you would set this up, it pretty much runs just like any other Dali system that you've encountered. Okay, so you can discover the Dali devices in Designer. Then obviously you can program them using actions, or you can even program them in the scene view within Designer as well, and send commands out to it that way. It's pretty much the same as any other Dali system. If you want to know what our Dali limitations are, obviously you can look in the help, but it's pretty expansive. For instance, if you're using an LPCX, you can have 100 Rio Ds. That's 100 Rio D interfaces, which means that you can have then obviously 100 gateways connected to each, 100 gateways connected to the system, obviously one gateway being connected to a Rio D. If you want to know a little bit more about how you would actually set up a Dali system, we have a whole webinar on that. As I said, integrating with the Casambi system is pretty much like programming any other Dali system. So make sure that you go back and have a look at that Dali webinar that we produced a couple of weeks ago if you're unsure about how you would go about programming that kind of system. Some great information there. And of course, you can always follow up with us as well at support@pharoscontrols.com if there are any other outstanding questions. So finally, I just want to finish off with a summary today of everything that we've looked at. So Pharos has some really powerful tools to integrate with third-party lighting protocols. Hopefully I've done enough to demonstrate that today. We have IO modules or existing protocols. Of course, we have other protocols such as DMX, TCP, UDP that potentially could be used with other systems as well. But in most cases where we're working with these third-party protocols, where they're using something like, I don't know, Zigbee or a Bluetooth mesh style network, you'll obviously need a gateway to act as a go-between between Pharos and the wider system. Should always check for compatibility first before obviously installing something. I know that goes without saying, but it's definitely advised. If you're ever kind of trying to figure out how you can integrate with a system, the easiest way to do it is obviously to find a common protocol that's shared between both systems, or at least find a gateway. Of course, if you're always unsure, you can always email support@pharoscontrols.com. We can give you our opinion and help you with that. But be careful with the types of protocols that you use or that you're going to be specifying for a system. Remember, DMX is very, very good for streaming data. It's very good for nice transitional stuff, mapping media to fixtures, doing dynamic content. But of course, something like Cicato wouldn't be particularly great for that, because it's command based. Because you're using HTTP, you're sending commands obviously to a gateway, which is then relaying the information. It's not streaming data. So just be a little bit mindful about the types of protocols that you're going to be specifying, on whether or not that protocol is a good fit. So I think that pretty much takes me to the end of my webinar today. I see that there are a couple of different questions that I'm going to just delve into now. If you do want to ask some questions, obviously feel free. You can raise your hand, just ask in the chat. Alternatively, as I've already said, you can email us at support@faroscontrols.com. So I'm just going to have a look at the question about from John. Are Faros in discussion with Casambi about direct integration? Baz, I think you know a little bit more about that than I do. So would you
Yes,
like to answer that?
I can pick that up. I mean, Faros is not planning to include a Dali, or sorry, a Casambi chip in their products. Would be a bit weird for us to ship out all our product with Casambi features, even though it will only be used in some occasions. That said, we are asking Casambi if they are willing to share their API. We see some devices in the market that should be able to translate their Bluetooth into Ethernet. We don't really know how Casambi feels on that, so that's what we're trying to work out at the moment. We know that there's a request from the market to make it happen. We're asking Casambi how we can work together to make it happen. And I get another question, how reactive is the Dali implementation? And it actually works pretty well. I mean, the approach from Casambi has been so far to offer a Dali gateway that allows all the Casambi devices to show up via Dali. And well, Faros is able to control Dali, as Ryan just mentioned, and that's all working out. That's all working out well. So I think at the moment, when it comes to Casambi, as Ryan mentioned, yes, Faros is able to control Casambi fixtures if you use their Dali gateway, because that will just make those the Casambi fixtures show up as Dali. Looking into a more native integration, we hope we are able to get there, but there's no current deadline for anything like that yet.
Yeah. So I see that Andrew's asked a question here. Will there be a Lutron module for integration? So obviously, yeah, in terms of Lutron stuff, I mean, Lutron uses Telnet. We have a Telnet module available that will allow you to integrate with Lutron as just a kind of as a module. Baz, is there future development going on to
No, I
make?
think you were spot on.
Yeah.
The way how Faros Designer supports integration with Lutron is via the Telnet module, and I know this. This has been verified and used on projects. If you would like to receive a example file of how this works, I know we have that available. So please just contact us via support@faroscontrols.com, because we should be able to get that file to you.
Yeah, I mean, I believe, Andrew, as you may already know, that Lutron, yeah, but as I've already said, the Telnet command, the Telnet module basically allows you just to send custom messages over Telnet. Okay, it's not like it's a Telnet module in terms of it uses the Telnet command. You can pretty much use any kind of ASCII-based string and just send that over the network. So we should be able to obviously support that, and obviously you can then just go away and just program your Lutron system to respond to whatever it needs to do. Any more questions? Is there any more questions? Just going to give everyone a couple of seconds.
All right, then I think I'm just gonna take over the screen again.
Yeah, brilliant. Thanks a lot, guys.
And let's be sure we set it up correct. Well, Ryan, first of all, let me thank you for this presentation. I think it was very useful to see those examples. I hope for everybody it was very useful as well. And as it was mentioned before, let me just check if these are questions. No. Yeah, I mean, if you have questions, please just feel free to reach out to us via email. This was the last webinar from this session. We expect to come back with some more webinars, but that will be a couple of months further in the future. After this webinar, you might receive a small survey where you can provide feedback, and other topics will be much appreciated, because as mentioned, we do plan to, in a couple of months from now, plan some more webinars. So with this, we'll be ending the webinar. I'd like to thank you for your attendance, and I hope to see you next time.